Hello everybody, we are here to discuss lesson 9-2. You've been graphing quadratic equations for a while and you know what to look for in order to find that vertex. You know how to find the y-intercept. You know whether it's going to open up or if it's going to open down. And now we're going to actually work on solving those quadratic equations and finding an answer for x. So, for example, if you have something like x squared minus 2x minus 8 equals 0, and you wanted to solve that. Well, if you look at just the stuff without the minus equals 0, you might say, well, you know, I think that might factor. I think I can find something that multiplies to a negative 8 and adds to a negative 2. And if I have a negative 4 times a positive 2, that multiplies to negative 8 and adds to a negative 2. So I can factor this to be x minus 4 and x plus 2, right? And that if that whole thing is equal to 0, then I can use my zero product property to say x minus 4 would be 0 or x plus 2 equals 0. So x is equal to 4 or x equals negative 2. So there are a couple of different ways. You already know how to do this. You already know how to factor it. But what does this actually mean? Well, if instead of factoring it out, if instead of doing that, we had actually graphed those points on our quadratic coordinate system, our Cartesian coordinate system, excuse me, and I had said, well, I'm not going to set it equal to 0. I am going to set it equal to y. So y equals x squared minus 2x minus 8. And if we just put a bunch of things in here and say, well, this is x and this is y, how are we going to graph that? Well, let's see. We can put in a 1, 0, negative 1, 2, negative 2, and so on, and see kind of where our points come out. So if I put a 1 in there, I'm going to have 1 minus 2, which is negative 1, minus 8, which is negative 9. If I put in a 0, it's going to be negative 8, right? If I put in a negative 1, it's going to be 1 plus 2, which is 3 minus 8, which is negative 5. 2 will be 4 minus 4. This is going to be a 4 minus 4, which is 0, negative 8. And a negative 2 is going to be 4 plus 4, which is 8. This is going to be a 0. And if we graph those, we can actually find that our that our y-intercept is at negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Got a point there. And we've got a point at 1, negative 9, negative 1, negative 5, 1, 2, 3, 4, 5, negative 1 is over there. 2 is negative 8, so a positive 2 is going to be right over here, and negative 2 is going to be up at 0. And you can graph your points like that. And you can see that it crosses this x-axis in 2 points, right? It crosses the x-axis at negative 2 and someplace over here, but we can't really tell because we didn't graph it quite as carefully as we could have. Well, there are a couple of things that you can do to figure that out. We can remember, well, you know, we did this the long way, right? We can remember that we have our y-intercept at negative 8, which we figured out right there. That's that point. We can figure out that our axis of symmetry is going to be at negative b over 2a, which in this case is negative 2, negative 2 over 2 times 1. So that's a positive 2 over 2, which is equal to 1. So that's going to be right here. That axis of symmetry is going to be there. And our vertex is going to be at the point where we put a 1 in and we figure out what y is going to be. So 1 minus 2 is negative 1, minus 8 is negative 9. So vertex is at y equals negative 9, x equals 1. So 1, 9, negative 9, which is right here. That's our vertex. Those are the points. So we can figure out where things are going to go or what it's going to look like. But unless we graph it very carefully, we're not going to be able to figure out exactly where those points are unless we do something like our factoring that we did over here. Okay? So when we solve by graphing, we're going to do the very best that we can. We do know, however, that it's from this point over to here and this point over to here where it crosses, it's going to be the same distance. So if we happen to have caught one of those points in our grid over here, if we happen to have caught one of them at -2, 0, we can know that it's negative, this is at 1, right? This is a positive 1. So we got 1, 2, 3. It's a distance of 3 here. It's going to have to be a distance of 3 over here as well. So if this is at 1, then we have 1, 2, 3. And this has to be, so if we're at 1, we're at 2, 3, 4. That's going to be at 4. So this is at 0, 4. And this is at -2, 0. And that's how we solve them by graphing. We're always looking for where it crosses that x-axis. That's going to be our answers. Okay, so why don't you do example 1A, pause the video and try it on your own, and then start it up again, and we'll see where it goes. So example 1A is the problem. -x squared minus 3x plus 18 equals 0. Okay, if we're going to solve by graphing, we're going to want to find our y-intercept. So the y-intercept is at 18. Our axis of symmetry is going to be at -b, which is -3, over 2a is a -1. Don't forget, if that's just a negative, that means it's a -1. Okay? So that's 3 over -2, which is -3/2. And finally, our vertex y-coordinate, we're going to put that -3/2 in for here. When we square that, that's going to be a 9/4, but that negative sign needs to stay with it, minus, that's going to become a positive 9/2 because I put this -3/2 in for this x. -3 times -3 is a positive 9 over 2 plus 18. And we want to just figure out that's going to be our y coordinate. So again, we change this to 18/4. 18/4 minus 9/4 is 9/4 plus 18. And if we change this to a number over 4, that's going to be a 72 over 4. 72 plus 9 is 81 over 4 equals y. So we need to graph 81 over 4, so it's helpful to know exactly how big that number is. So 4 goes into 81 20 times and 1/4. Okay? So if we graph that, we have our y-intercept up here at a positive 18. 18. We have our our vertex at, let's see, our y-intercept was 18. Our vertex is going to be -3/2 and 20 and 1/4, or 81/4. Either way is correct. So -1, -2, so this is -1.5. Here is 20. And then it's going to go through both of these points, so it's going to go down. And you're going to have a number here and a number here, which are going to be your answers. So we know we're going to have a positive number and a negative number. And if we think about it, you know, if you did this on graph paper, you can probably get pretty close. The answers here are actually 3 and 6. Those are our answers. And they're guesses, and they're going to be they're just going to be guesses at this point. You want to make sure they're close. You should be able to tell that this is a -6. You should be able to tell that 1 is a positive and 1 is a negative, and that's the big thing. Just do the best you can. When we're graphing like this, there's a limit to how well you can do. But don't make it too sloppy either. You should notice by now that if you're always looking for places where where it crosses the x-axis, please excuse our sound effects over here, that there are lots of different situations that you can get into. And one of them is like what we've just seen, where we have a parabola that crosses the x-axis like this. And when it crosses the x-axis twice, you are going to have two solutions. Important detail, two solutions. Sometimes you're going to have something that crosses the x-axis. It doesn't actually cross it. It just comes down and touches it, and then it goes back up again. And when that happens, you are going to have one solution. Okay. Can you come up with any other ideas on what else might happen when you're graphing these? You can actually have a situation where it doesn't cross at all, where your parabola just kind of hangs out and doesn't ever cross the x-axis. And when that happens, you will have no solution. That is a possibility. So let us look at example 2, where it says that we're going to get a double root. Example 2 is a problem that says x squared minus 6x equals minus 9. X squared minus 6x equals negative 9. Okay. So when we're graphing this, we're going to bring that negative 9 over, and we're going to replace the 0 with a y. So it's going to be y equals x squared minus 6x plus 9. All I did was bring this negative 9 to the other side of the equal sign. Okay. We're going to graph this. First of all, our y-intercept is going to be at 9. That's easy to pick out. Our axis of symmetry, we find that by doing a negative 6 over 2a, which is 1. So that's going to be a positive 6 over 2, which is 3, our axis of symmetry. So we know we have our y-intercept at a positive 9. That's our y-intercept. Our axis of symmetry is at 3. 1, 2, 3. That's going to be right there, our axis of symmetry. And to figure out our vertex, we are going to replace this 3 in there. So we'll have a 9 minus 6 times 3 is 18 plus 9. So our vertex is going to be at 9 minus 18 is negative 9 plus 9. Negative 9 plus 9 is 0. So it's going to be at 3, 0. 3, 0 is right here. That's our vertex. And here we go. And that's the way it's going to go. So you can see that when our vertex is right on the x-axis, that is going to be just coming down and touching the axis and then going back up. When that happens, we have a double root. And the only answer that we're going to have is at x equals 3. One answer because it touches there and it goes back up. Now you try 2b. 2b. Stop the video, do 2b, and start up again with me in a moment. 2b is x squared, that says x squared equals negative 8x minus 16. So that's going to be x squared plus 8x plus 16 equals 0, or y equals that. Either way, you want to think about it because we're graphing. We want the whole thing to equal y, and you can just stick a y in there. It feels kind of weird, but you can just do that because you're graphing this part of it. And when you graph this part of it and you find where y is equal to 0, that's going to be our answers. So again, let's start with our y-intercept. Y equals 16 is our y-intercept. And we might as well go ahead and put that on here. We'll just say that that's 16. Okay. If you have a grid, make sure you're counting. You don't have to count 16 blocks up. You can count 4 blocks up, or something. You can do something where maybe 2 blocks is equal to 1, or 4 blocks is equal to 1, or something. Do something to make this easier so that you don't have to count up off your page that way. But stay on the grid and use the grid. Don't just stick a number on here. I don't have a grid, so I can't use it, but please use your grid when you're graphing. Y equals 16 is our y-intercept. Our axis of symmetry is going to be a negative 8 over 2 times 1, which is a negative 4. So if we put our axis of symmetry in here, it's going to be about at a negative 4. Remember to use your grid. Negative 4. And we can figure out where our vertex is going to be by putting that negative 4 into this equation. So our vertex is going to be a 16 minus 32 plus 16. So 16 minus 32 is negative 16 plus 16, 0. So negative 4, 0 is where our vertex is. Did you all see how I did that so quickly? I put this negative 4 in here. X squared, negative 4 squared is a positive 16. 8 times a negative 4 is a negative 32. 16 is just 16. So then we add and we get a 0. So our axis of symmetry is going to give us our x coordinate, and our y coordinate comes from our substitution, and our vertex is at negative 4, 0. Here, let me put a negative 4 there so we remember where that is. It has to go through those points. So it goes through the vertex and it goes through there. It's going to open up. It's going to open up. And there we go. And we can see that since it only touches the y or the x-axis, that we're going to have a repeated root or a double root. And we're only going to have one answer. That is going to be x equals negative 4. Okay. Alrighty. So that's that. I'll give you one example for when we have no real roots. And let's see what happens there. This example is 2x squared minus 3x plus 5 equals 0. Everything's already on one side of the equation, so I can just say that's going to be y equals that. Okay. And again, we're going to look for our y-intercept. Y-intercept is at 5. And let's do this. So we have 1, 2, 3, 4, 5. And now we want to find our axis of symmetry, which is going to be a negative 3 over 2a, which is going to be a 3/4 at positive 3/4. So here's 1, and there's our axis of symmetry at 3/4. And I'm going to put that in orange so you can see it. So it's really, really close at 3/4. Now we put 3/4 in there, and we should see that we get, for our vertex calculations, we'll have 2 times 3/4 squared is going to be 9/16 minus 3 times 3 is 9, 4 is on the bottom, plus 5. So this is going to give me a 9/8. 2 goes into 16 8 times, minus, well, since I want a common denominator of 8, this is going to be 18, and then plus over 8, this is going to be 40. 9 minus 18 is negative 9 plus 40 over 8. This is going to be a positive 31 over 8, which is almost a 4, right? So this is going to be 3 7/8. 3 goes into 24 3 times, and 31 minus 24 is 7. So that gives me 7/8. 3 7/8. So that's 1, 2, 3, 4. It's going to be just under the 4 and it's going to open up because it's got to go through that y-intercept. This one will never ever cross the x-axis, so there are no solutions. Okay, what do you think about that? What do you think about that? You like it when there's no solutions? Less graphing, perhaps? Anyway, this is our review for Lesson 9-2. You can go ahead and do your own homework. Bring your questions to class. Enjoy your homework, and I will see you in class.